In this video, we'll understand algorithmic bias in a simple, practical way. We'll see how unfair outcomes can emerge in AI systems, not because machines have opinions, but because data, design choices, and human interpretation can carry bias into the system. We'll also look at real examples and the steps organizations can take to reduce these risks. And yes, there will be short quizzes in between, so you can check your understanding as we go. Algorithmic bias happens when machine learning systems produce results that are unfair or discriminatory in a consistent way. Very often, these outcomes reflect existing socioeconomic, racial, or gender bias already present in society. Since AI systems use data to find patterns and make predictions, any unfairness in the inputs or process can influence the final decision. This becomes especially serious when AI is used in areas like hiring, healthcare, or law enforcement. Biased algorithms are not just technical issues. They can lead to harmful actions, unequal treatment, and loss of trust. Imagine an AI system influencing who gets hired, who gets a loan, or who is flagged by police systems. These are life-altering decisions. On top of that, organizations can face legal trouble, financial penalties, and reputational damage if their AI systems are found to be unfair or non-compliant with regulations. An important point here is that the algorithm itself is not magically biased on its own. Bias usually enters through the way data is collected, labeled, designed around, and interpreted. The article highlights 4 main sources: bias in training data, bias in algorithm design, bias in proxy data, and bias in evaluation. So if the surrounding process is flawed, the AI output can also become unfair. Data bias is one of the biggest causes. If the training data is incomplete, unrepresentative, historically biased, or simply poor quality, the model can learn those same patterns. Then, when its output is used again as input for future decisions, a feedback loop starts. Over time, the same unfair pattern keeps getting reinforced. Another issue is that models may learn correlation instead of causation. For example, 2 things may occur together without one actually causing the other, but the system may still treat them as connected. Now that we've covered bias basics, let's test what we've learned so far.
Here's quiz number 1. See if you can get it right.
Question 1. What is algorithmic bias mainly about? The correct answer is systematic, unfair outcomes from AI systems. Correct. Algorithmic bias refers to consistent unfair or discriminatory outcomes produced by AI or machine learning systems. Question 2. Which of these is a major source of algorithmic bias? The correct answer is training data issues. Yes. Biased, incomplete, or historically skewed training data is one of the most common causes of algorithmic bias. Question 3. Why are feedback loops risky in AI systems? The correct answer is they can reinforce the same bias over time. Exactly. When biased outputs are reused in later decisions, the system can keep learning and amplifying the same unfair pattern. Bias can also enter during algorithm design. Developers might assign weights to factors in a way that seems reasonable but actually introduces unfairness. Sometimes subjective assumptions, conscious or unconscious, get embedded into the system. Then there is proxy data. This is when the model uses something else as a stand-in for sensitive attributes like race or gender. For instance, postal code may be used as a proxy for economic status, but in practice, it can also map closely to race or community background, leading to unfair treatment. Even if a model is technically neutral, bias can still appear in evaluation. This happens when people interpret or apply the results based on their own assumptions instead of objective evidence. In other words, the AI output may be data-driven, but the final human decision can still be unfair. So fairness is not only about model building, but also about how outputs are understood and used in the real world. When algorithmic bias is not addressed, it can reinforce social inequality and harm already marginalized groups. It can also expose organizations to lawsuits, regulatory penalties, and public criticism. A key legal concern is disparate impact, where a seemingly neutral policy ends up affecting protected groups unfairly. And finally, trust gets damaged. Employees, customers, and the public may stop believing that AI systems are reliable, fair, or worth using at all. The article gives many real-world examples. In recruitment, Amazon scrapped an AI hiring tool after it disadvantaged women because it had learned from mostly male resumes. In healthcare, underrepresentation of minority groups has led to lower diagnostic accuracy for some patients. In criminal justice, tools like Compass have faced criticism for possible racial disparities. Similar concerns have appeared in mortgage pricing, facial recognition, image generation, and even ride-hailing fares. So this is not a theoretical issue at all. It affects multiple sectors. Now that we've covered risks and examples, let's test what we've learned so far.
Here's quiz number 2. See if you can get it right.
Question 1. Which of these is listed as a major risk of algorithmic bias? The correct answer is loss of trust. Correct. Biased A. I can erode trust among customers, employees, stakeholders, and the wider public. Question 2. Why was Amazon's AI recruiting tool criticized? The correct answer is it discriminated against female applicants. The tool learned patterns from past hiring data that was dominated by male resumes, leading to unfair outcomes. Question 3. Which sector is mentioned as being affected by algorithmic bias? The correct answer is healthcare. The article specifically mentions healthcare as one of the areas where biased AI can create serious harm. Reducing algorithmic bias starts with strong AI governance. That means putting proper guardrails, standards, and accountability across the AI lifecycle. The article highlights a few key ideas. Use diverse and representative data, actively detect and mitigate bias, improve transparency and interpretability, and build systems through inclusive design and development. The main idea is simple. Fairness cannot be added at the end. It must be built in from the beginning and checked continuously. That's it for this lesson. If you understood where algorithmic bias comes from and why it matters, you're already thinking more critically about AI than many people do. Keep asking who built the system, what data trained it, and who could be unfairly affected. That's how responsible AI starts.